Um, yeah, welcome into our Unitarian Church of Montpelier. My name is Sandal Kate, and I'm one of a team who have organized 3 lectures. This is the third of our winter series, but now we're into spring. And thank you for supporting our series with your presence and your interest in all things ecology. Couple quick things. Restroom, one there, one around the corner immediately to the left of this door, one immediately to the right of that door. And if you still have a little hankering for a nibble or two, feel free to get up and get something more, because we had a lot of contributions. So we're going to get started, and we will hear from our presenter after a few comments here. First of all, our committee, which is Abby Callahan, who greeted you, Mary Jane Olson, Peter Watt had company arrive on his doorstep, so he came, helped, and had to leave, and Kathy Johnson had to be out of town also. So our whole team couldn't be here, unfortunately. We all wanted to hear all the speakers, but it's hard when you have a conflict. So we've had a lot of support from our church staff as well. This church received a generous donation from a member last year to sustain the endowment for the series. And with your participation, we're very happy to keep the series going. Additionally, we will appreciate any help after the lecture with folding up chairs, hanging them, all going the same way. That makes a difference. You can get more in that way. And if you don't mind helping to move the vases of flowers to the back white shelf, and then there will be a milk crate for the tablecloths, and then the card tables get folded up, and there's a cart over against the wall over there. Again, if you're able to, don't feel obligated if it's too much work or you have to leave early, but many hands make light work. Thank you. So this series is named in the memory of Grace M. Clarke. She was a teacher at Union Elementary School between 1905 and 1940. So I don't think any of her former pupils are here. Could be, but maybe not. And Union School, having been rebuilt in 1939, and I was a teacher there for a number of years, it would have been a wooden school building. And in that bathroom, there happens to be an old picture of looking down School Street, and you can see the old school down there. I don't know if that photo came from Grace Clarke or not. She was an ardent interpreter of nature, and she actually produced 2 local field guides to the birds and trees of Montpelier. She founded the first local chapter of the Audubon Society here in the area, and developed special nature learning materials for schools that were shared around the whole state. Some students affectionately called her Birdie Clarke, but not to her face. She passed away in 1960 at the age of 88 and had been attending this church and left a small legacy to our church, which became the source of funds to start the series in 1970. So it's been going for a while, and I'm sure many of you have attended in the past. We hope you enjoy the continuation of Miss Clarke's legacy. And in recognition of April as Poetry Month, and Montpelier being known as Poem City, I made a little ditty up for tonight. Grace Clarke would think it grand that we learned a history of our land and how to watch the birds at hand, than ice core studies of Greenland. We thank you all in our bandstand. We do have Orca here. This is the first time that Orca has filmed us, and we're delighted to give it a try. So somehow in the future there will be a recording of this, and I know we can at least get word out through our church e-news. I don't know how somebody else might find it, but I guess Greg, can you check the Orca site somehow for what's available?
Yes, you can go on Orca's website or something.
Okay, and do you have an idea about whether it's a week from now or 2 weeks from now?
I can't say that for certain.
Okay.
It could be very soon.
Okay, so say within a week. You know, if you want to find the link and then pass it on to friends or family who would be interested. Okay, with all the business at hand taken care of, tonight's presenter is Dr. Paul Bierman, a professor and researcher at UVM's Rubenstein School of the Environment and Natural Resources. He'll be speaking about Greenland, ice cores, and climate change, as you can see on the screen, which is shared in his newest book, When the Ice is Gone. And that is, you can do a little shameless promotion over there, available for sale. Would you like to hold up a copy? Just give it a little wave.
Sure.
Thank you. He is a geomorphologist, and that's quite a mouthful unto itself, with wide-ranging interests which include isotope geochemistry, surface processes, and then changes that are caused by humans and by rates of erosion. He is particularly interested in working at the interface of active research, education, and science literacy at all levels. We learned of his work from an interview on Vermont Public Radio. Welcome, Dr. Bierman.
Thank you. Okay, so the first thing is, can everybody hear me okay? Volume good? All right. And can everybody see? I'm trying to make sure I'm not in Larry's way. Or
Tell me how much light you want.
It would be great. Perfect.
Is that good?
That would be easier to see the slides.
Okay.
Yeah. Great. Okay, well, thank you, everybody, for coming out on what feels like the first spring or maybe almost summer evening. I'm not used to this humidity after this weekend. And yeah, so it's an interesting night and month and year to talk about Greenland. So I'm going to take you through what I would say could be at times a slightly confused odyssey of a mixture of history, science, and politics. And we're going to look at Greenland from those various kinds of lenses. So again, I'm a faculty member at the University of Vermont. I've been there since 1993, which is all of a sudden seeming like a really long time. I'm in the School of the Environment and Natural Resources, and the work you're going to see tonight, and I think this is really important to say, has been supported, as has the laboratory I've built and the people who work with me, by the U.S. National Science Foundation since 1993. And that is dramatically at risk right now as the National Science Foundation is being decimated in a whole lot of different ways. So I really have to say a huge thank you for the foundation for enabling me to have a career and to do the research that you're going to hear about tonight. Also, the Gund Institute at the University of Vermont, which is an amazing interdisciplinary institute for the environment that I would encourage all of you to investigate. They have great talks, a lot of public-facing talks, and a lot of discipline crossing. Okay, enough pitches for that sort of thing. I just thought I'd show you that I have been fascinated with glaciers and what they do since I was, I think, 21 in that picture, and I had a lot of hair, and none of it was gray. There. I went to Williams College. I graduated in '85. I should have graduated in '84, but I needed an extra year to figure out what I was going to do. And my senior thesis involved looking at what the ice sheet had done in New England, particularly in western Massachusetts and southern Vermont. And that is one of the larger glacial erratics. That rock was moved by ice. So I have always been fascinated with ice, and I spent most of my career not looking at ice, but looking at the sand and gravel and rocks that the ice moved around. And it wasn't until 2008 that I actually got to Greenland and saw a real ice sheet for the first time in my life. And that's Greenland. This is the first night I spent camping in Greenland, the second night I was on the island, and that is the Greenland ice sheet, and this is about 9 o'clock at night. Because we were there in the summer and we're almost at the Arctic Circle here. It was the most spectacular campsite I have ever had in my life. Until the next morning, because we had a huge windstorm, and I believe that tent in the middle that's got like mesh was the tent I had. And all the sand from this gravel pit blew into the tent, and I woke up with this little sand dune in front of my face. It was still a spectacular place. And I got really lucky that we were supported for 4 different years by the National Science Foundation to do field work there. We collected a lot of rocks. We flew in a lot of helicopters. Sometimes we collected sediment from streams. Sometimes we got a hammer and chisel. So I got to see East Greenland, South Greenland, and West Greenland in those 4 years. And our goal was to try to understand the history of the ice sheet. When was it larger? When it had gotten smaller? How did it alter that island? But the real fun has happened to me since 2019. And this is the mix of history and science that I wanted to spend most of the time on the talk in. In 1966, at a place called Camp Century, how many people in this room know about Camp Century? If you know about it, raise your hand. I see 1.5. Okay, 2.5, great. So Camp Century was a US Army base built inside the Greenland ice sheet in 1959 and 1960. Think about that, an Army base inside an ice sheet. And I didn't know about this till graduate school, and I barely knew about it. It's up here in northwestern Greenland. And at that base, the Army, for the first time ever of anybody in the world, drilled entirely through an ice sheet and got to the bottom. Almost a mile thick of ice. And they did that in 1966 when I was out of diapers and I wasn't toddling, but I wasn't in school yet. So in my lifetime ago, they did something that has never been repeated, which is drilling through and to keep going. We've drilled through many ice sheets since then, but so far, no one's gotten as much material from the bottom. And that is that core. This is a guy named Chester Langway, who actually is still alive. He's almost 100 years old. He was the head geologist, and this guy, Lyle Hansen, was the head driller there. That core, in particular, this frozen soil from beneath the ice sheet, almost 12 feet of frozen soil that kind of looks like the snowbanks at the end of February, early March, after we've had a rainstorm and it's been plowed up in your driveway and all that. It's a mixture of ice and snow. That was lost between 1994 and about 2018, and then it was refound. And I'll talk a little bit more about that. And we were incredibly lucky to be given 2 pieces of that, and the group in my lab has been leading an international investigation of this almost 12 feet of frozen soil with something like 40 people, 7 graduate students, 20 institutions, 5 countries represented, because in this is a history of Greenland's ice sheet in that frozen soil. So zoom forward to 2021, and we published this paper, which I am sure no one in this room has read, even though it's in the Proceedings of the National Academy of Sciences, so it's actually free, open access, if you want to read it. But the title is not particularly stimulating unless you happen to be a climate scientist. A multi-million-year-old record of Greenland vegetation and glacial history preserved in the sediment beneath 1.4 kilometers of ice at Camp Century. I can't say that without breathing. It's such a long title. That paper actually changed the way people started to think about ice sheets, because it said under the ice sheet is a history buried in those sediments. And we can read that history. But the reason I put that up here is a week after this was published, and it made a fair bit of news splash. I got a call from a senior editor at Norton who said, "We want you to write a trade book." And I'm like, what is a trade book? I've written 2 textbooks, and I've written 200 scientific papers. That's a genre I knew how to do. I had no clue how to write anything like this. And so I was pretty skeptical to start. I'm like, well, this sounds kind of fun, but I don't know the style. And she's like, don't worry, that's why I'm an editor. And she said, we will beat the textbook writer out of you, trust me. And 3 drafts later, she and her assistant had beaten the textbook writer out of me. And I learned a whole new genre at age, 59, 60, 61, which was a whole lot of fun. But that's how this came about. It was really a sort of happenstance phone call that she'd read something, I think maybe in the New York Times, and thought this would be a cool story. Okay, so let's talk about Greenland now. So this is the island of Greenland, and the ice sheet is not that color. This is what NASA does to ice sheets when they want to show you how fast the ice is flowing. So where it's red is the fastest ice flow, and where it's green and yellow is the slowest ice flow. And you can see big fjords here. This is the fjord at Ilulissat, which by rumor issued the iceberg that sank the Titanic. Maybe yes, maybe no. But something like 7% of the loss of ice from Greenland happens through this fjord system here. What you should notice is that over 80% of the island is covered with ice. So there's only about 20% on the coast that we as geologists can actually go see and do things. The rest is buried under ice. And Greenland has been, since the beginning, a melting pot in various ways. I'm going to focus on the human part of that. But the first people to come to Greenland were the Thule people. That's about 5,000 years ago. And they came over the Arctic North, and then the Inuit came, 2 waves of Inuit peoples. Then the Norse appeared, then the Danes, and then the Americans. And in between, the French showed up for a little while, and the Germans were there for a bit. But the main peoples were these. And we know something about the original Inuit at contact, at Western contact, which was a couple hundred years ago, and how they lived. We know a lot more from archaeology of the people who lived there. And we know, for instance, that they were primarily a society that got their food from marine realms, from fishing. Various isotopic studies can tell us that, and marine mammals. We know a fair bit about the Norse, again, archaeologically. There are very well-preserved Norse sites on Greenland. Has anybody been to see those? They are just spectacular. To be able to walk around someplace where you knew the Norse were walking around 1,000 years ago. We sampled in one town that had that, and literally there are these Norse ruins, not this one, but the sheep are grazing all around them. And you're sitting there eating lunch, sitting on a rock that a Viking could have sat upon 1,100 years ago or something. So really fascinating place. And then in 1722, the Danes come to Greenland, and it's this man named Hans Egede who was looking for why the Norse disappeared. So he wanted to know, I'm going to go to Greenland and find the Norse. He was very religiously trained, and the Norse were Christian, and they set up a bishop's seat in Greenland. He did not find any Norse because their civilization ended about 1400 CE. And there's no indication it ended by violence or starvation. They just left. And probably they left because the climate had gotten colder, the ice sheet had gotten bigger, it had pushed Greenland down, and their coastal sediments were flooding because the sea level was rising, which we'll come back to a little later. And by melting pot, not only culturally a melting pot, but genetically a melting pot. And I know with this projector, you can't read this, but this is a study of the genetic history of Greenlanders today. And something like 25% of, this is the Greenland Inuit genome, is actually Danish. So there's been interbreeding in the last couple hundred years. The other genome that's represented here is from Norway. And that's probably the Viking interbreeding with the Inuit people who were there. So it's a melting pot in many ways. It's also a melting pot culturally. So these bright, colorful houses that you see in Greenland look a lot like parts of coastal Denmark. And so that culture of building houses that look like this and are painted in bright colors is certainly Danish, but the landscape is definitely not Danish. Greenland's also a stepping stone to the North Pole. And I should have said, and I should have told you when you introduced me, that I'm actually kind of a closet historian. And maybe that's the geologist in me that likes to figure the history of the Earth, but I also really like to look at the history of the places in which I'm working. So Greenland as a stepping stone to the North Pole is based primarily on this guy, Commander Robert Peary, who claimed, and it's a disputed claim, to be the first to reach the North Pole. And he had with him a person named Matthew Henson, and this is not particularly well known, who was a black man, and who probably was the first one to the putative North Pole that Peary says he got to, if he actually got to it, rather than Peary. And they took a number of trips to Greenland. This is their ship in an earlier trip to Greenland, not the one where they made it to the pole. And this is the photograph they took when they claimed they had reached the pole itself. And again, the analysis of whether they got there or not is based on things like shadow angles here and their dead reckoning and their journals. There's another fellow named Cook who claimed to have gotten to the pole first. I do not have a strong feeling on who, if either of them, actually got there. But the New York Times, of course, figured prominently in this. This is Commander Peary's preliminary account of his successful voyage to the North Pole. But right here it says, Cook not near pole, says Peary. So that's for the history books. But in any case, this is one of numerous adventures to Greenland, occupations of Greenland. So what we're seeing politically right now is nothing new. The native peoples did not fare well by Peary. So this is a very large meteorite that's being carried on rails to his ship here. this was the source of iron for the native peoples. So when the explorers showed up, they were shocked to see people with metal tools in Greenland going, these people don't have smelting. But they didn't need it because this was a multi-ton meteorite that was iron, an iron meteorite. And so what Perry did was took that meteorite back and put it in the American Museum of Natural History in New York. In fact, he brought several fragments back. There's another fragment in Denmark, too, of the same meteorite. This is one of the native tools that's tipped with an iron blade, sharpened iron blade made from that meteorite. You can tell by the chemistry of both of those. I thought that was just fascinating, that people are using this natural source of iron that fell from the sky. The explorers fathered children with Inuit women. Those children actually know of their fathers from Henson and Perry and trace that lineage. This is just a family portrait I found on the web of some of those descendants. This is probably the most shameful piece of this, well beyond the meteorite, is that in 1896, Perry took 6 Inuit with him to New York for study. So he took them from northwest Greenland back to New York. And then the Museum of Natural History put them on display, and 20,000 people looked at the native Greenlanders. All of them contracted tuberculosis. One child, a person whose name was Minnick, survived only to later die from the 1918 flu epidemic. This is a photograph of 4 of those 6. Minnick is the child here. And that is taken in New York. So imagine taking people from the farthest wilds of northwest Greenland and bringing them to New York City by ship. It has even a worse coda, I guess, or ending to this. One of Minnick's dad, actually, one of the men died, and they staged a mock funeral, but in fact the museum kept his bones for study and apparently displayed those bones, and the story is that Minnick saw the bones in the museum of his father. The museum kept those bones until the 1990s when they were repatriated. So it's a pretty shameful piece of history of Greenland brought to the US. All right, let's go forward to sort of the next explorers in Greenland, and this is a fellow named Alfred Wegener. Does that ring a bell with anybody here?
Oh, yes.
So what did Wegener do? What's his claim to fame?
Continental drift.
Continental drift, yeah. It turns out he's a meteorologist by training, and he dabbled in the continents. So one of his big meteorological expeditions, in fact he went several times, was to Greenland. His last expedition is 1930-31. He established a camp called Ice Mitte, the middle of the ice sheet here, and another camp on the west side, another camp on the east side. And then he, for some reason, worrying about the center camp, took one man, a dog sled team, went from the west camp to the camp at the center in the middle of October. By then it's getting dark, it's getting cold, it's getting stormy, and on the last day of October, this is the last photograph of Wegener alive, he left Ice Mitte and he went to the west coast and never got there, and died on the way. But the man had people taking film with him, and this is digitized film. Hopefully it will play from here. There we go. Digitized film of that expedition. And they're starting at the edge of the ice sheet. There's many, many minutes of film, and they have to carry all their stuff up. And so they're packing it. The edge of the ice sheet is full of crevasses. It's extremely steep. It's extremely rough. It's bouldery. Once you get up top, it's actually relatively easy to move around, but they had to get through this crevasse zone, like that. They're obviously packing quite loads, but the special thing about this expedition is they were the first motorized expedition on Greenland. And these were a weird hybrid of an airplane and a snowmobile. They have runners. They have an area 2 or 3 men can be in that's shielded from the elements. And then they put an airplane propeller and motor back here on the rear of that. And you can see how steep that is, right? So we got the horses, they've got the winches, but then they put the engine on, they put the blade on, and off they go across the ice sheet. And that revolutionized travel. Now to realize that, you know, with the Industrial Revolution, fossil fuels, and the ability to use mechanized transport. So that was one of the big things that came out of the 1930 expedition. But this is I added this slide, so this is a newbie for me. Continental drift, Wegener's grave with these aero sleds there. They found the grave. His partner buried him after he died. The suspicion is he actually died of a heart attack in the ice and was left in his sleeping bag, zipped up, buried here. They never found his assistant or the person working with him. So somewhere there, and there's a Greenland postage stamp of all of this that I like that. Okay, this is the other really cool part of this expedition. So 3 men lived inside the ice in the winter of 1930-31. They are the first people we know of to live inside an ice sheet. They dug a massive interconnected set of snow caves. They built sort of igloo-like structures at the top, and they took weather measurements a couple times a day, as long as they could safely get out there. They had ropes leading them to their weather observations. This is where they slept. There's their bunk. Here's a little stove for cooking in there, air vent, storage. Could have a lot of frozen storage there. And these are the 3 men. And they're in their sleeping bags. This is their snow cave, their little alcohol stove. Apparently the temperature was something like 25, 26 degrees Fahrenheit at the top and about 0 Fahrenheit at the floor. It would thermally stratify, but no wind, and you can easily live in your skins and your sleeping bags at 20 degrees. No problem, all winter, and they did. They survived. The thing they did, though, that we still think about today as glacial scientists, and I wonder if they just got bored. It's this guy named Ernst Sorge. He's the geoscientist of the bunch. This is Franz Lowe, who's a meteorologist, atmospheric scientist, who went on to a very famous career in Australia. These two spent an entire winter together. Sorge became part of the Nazi Party soon after, and turned in Lowe, who was arrested because he had Jewish blood. And it was only apparently family of Wegners who intervened and said, let this man go. He's done such amazing things. And the agreement was he could leave Germany, and he immediately went to Australia. So it's a fascinating history between these two. I mean, imagine turning on someone that you had spent 6 months living in a cave with. Anyway, Sorge is known for digging this set of stairs. So this is a cross section. So we sliced the snow, and he dug stairs, and as he dug the stairs, he took blocks of snow all the way down, and then he got to the bottom of his stair digging and went vertical, and then he took a little cord at the end of that. And this is a sort of demonic-looking picture of it. Anybody know why he looks so demonic in here? There's actually a very practical explanation.
It's cold.
It's cold. It's also really dark. And so this was probably a very long exposure photograph, and he had to freeze to do that. It's probably a couple seconds of exposure. Anyway, he's cutting a block of ice into a rectangular solid so we can measure the volume of it. And then he's got this balance hanging here so we can measure the weight. And from that, you can calculate the density. All right, that sounds pretty scientific. It is. But what he showed is that the density at the surface was quite low compared to the density 14 meters down. The other thing he showed is that there were layers of dense and not dense, and dense and not dense, and dense and not dense, this dance back and forth and back and forth. And he showed in the winter that he stayed there, this top gray bar, that the winter snow was denser than the summer snow because the wind blew harder and it knocked all the little edges off the fancy crystals, and you had a much denser snowpack at the end of that. So this let him count back. That's 1930 winter, 29, 28, 27, 26, down to 1911. So he counted back to 1911 from 1929, there, 1930. This proved for the first time that ice sheets were like a layer cake. And that meant to a geologist, if they're layers, there's history. So this was a fundamental observation by a guy who spent 6 months buried in an ice sheet. And who later turned on his friend, but it is the biggest thing that came out of their work. They did other really cool stuff. They blew up explosives on the surface, and they had seismometers, and they estimated the depth of the ice sheet for the first time to within 10% of what we know it is today there. So just amazing stuff for 1930. All right, let's pop again ahead in time with our history. We're going to go to World War II. And in World War II, and I guess that history is becoming even more relevant in the last couple of years, we were supporting the Allies, but only sort of. With the Lend-Lease Act, we were very insular at the United States. We didn't want to get involved in World War II. But then Roosevelt signed the Lend-Lease Act, and we started supplying munitions and airplanes to Europe. The problem was the North Atlantic in 1940-41 was controlled by Nazi U-boats. It was not a safe place to put large transports and send, say, 30 airplanes across the ocean. So instead, the Army Air Force, which was the flying wing of the United States military at that time, flew the planes from North America to Europe. They would fly to Presque Isle, they would fly to Gander, Newfoundland, and if they were bombers with a large capacity, they could fly all the way to Great Britain. But if they were smaller cargo planes or fighter planes, they would fly Presque Isle to Goose Bay, and then they would fly to one of two bases in Greenland, and then they would fly to Reykjavik in Iceland, and then to Scotland to get there, because they could only fly 800, 900, 1,000 miles before they ran out of fuel, and then they would refuel. So this meant the US had to build bases. They built the airport at Reykjavik that I bet some of you have flown into. That's an American World War II air base. They built the US air base at a place called Narsarsuaq, which is also known as Blue West 2 on South Greenland. They built another large airstrip at Blue West 8, which is Kangerlussuaq or Sondestrom. Only this year did the capital Nuuk in here get a long runway for big airplanes. So for many years, the only two places you could fly in big jets were the two old US air bases that were there. Now, at this time in the 1940-41, they did not have radar on the planes. They had rather crude weather forecasting, and things didn't always go well when you flew across the ocean into the ice and you didn't always get to where you thought you were going. So in the end, a lot of these planes landed on the ice sheet. By October, I think it's either 40 or 41, I think it's 41, something like 10% of the planes that were flying across didn't make it. And a bunch of them that didn't make it on the ice sheet. And then things got even worse because there were about a dozen US bases scattered around the southern part of Greenland. And they were set there to rescue folks. They went out with snowmobiles that broke down. They didn't have proper clothing. People were dying during rescues. There were crews who spent, I don't know if you can see it, there's a tent erected on the tail of this airplane. Men would be spending weeks to months being airdropped food and supplies before they could get them off the ice. So World War II really showed us we did not know how to operate in cold regions. And there was a huge concern about weather, and I'll just take an aside. This is the westernmost battle of World War II, and it occurred on East Greenland, and it was where the US Coast Guard captured Nazi weathermen, dozens of Nazi weathermen, because they had built weather stations along East Greenland, and we had built our weather stations across West Greenland, both to do the same thing, forecast the weather in Europe. And the Coast Guard, in a dog sled patrol, found the Nazis and captured them. I don't really think there were any shots fired, anything like this, but they took them captive on a Coast Guard vessel. One of the things they figured out in World War II is when planes crashed, if the snow and ice were in a smooth enough condition, they could land seaplanes on the ice sheet. And that is a seaplane, it's called a PBY, and it's a monohull here, and so it lands, like this, the fuselage lands right on the ice there. And they did it, and they took off, and they realized they could do rescues that way. That too changed how we think. But the end result in the late 1940s was the Army Corps of Engineers said, we got to figure out how to work on snow and ice. It's a military liability if we don't understand it. So they started something called the Snow, Ice, and Permafrost Research Establishment. Perhaps only the Army or the government could have a name that long. And it was abbreviated SIPRI from the first letter of each of those words. And they hired this guy by the name of Henri Bader to run it. Bader was a Swiss geologist, trained in minerals, of all things. Got his PhD and said, I need a real job, and went to work for the Swiss Avalanche Prediction Center, because what is frozen water but a mineral? And so he could apply what he learned from working on rocks to ice, and then left, and this is a whole other story that I talk about in the book, but I don't really have time to talk about tonight. He left Europe a year before Poland was invaded. Went to South America, spent part of the war in South America, part of the war in Curacao, and within 3 weeks of the end of the Victory in Europe celebration, he was in the US. He worked in a mine in Curacao that produced the most pure phosphorus in the world. Guess who wants pure phosphorus? And why?
Clockmakers.
Yes, and the US military for munitions.
Phosphorus is incredibly flammable, and it burns for a while, and it sticks to things very, very well, so
Yep.
Pretty much bio. Bleh, can't think right now. I don't know what the word would be. Just biological napalm. It's not biological. It's just
Elemental.
primitive napalm.
Yeah.
Primitive napalm, basically.
Yeah. It burns very brightly, so it's used for flares, so it's used for munitions. Anyway, I don't think it was an accident that he was mine superintendent of the mine producing the most valuable phosphorus in the world at that point. So Bader comes to the United States and very quickly is part of the employ of the US government. Again, like I talked about with the last explorers, I want to come back to the US impact on the native peoples in Greenland. As I was working on this book, one of the things I learned how to do that I'd never done before, and I don't think I've done again, is buy things off eBay. Because it was COVID time, the National Archives was closed, I would be Googling and I would find photographs of Greenland in the 40s, 50s, and 60s. And then I'd realize somebody wanted to sell me this for $5 on eBay. And magazines, and my kids were stuck home at the time, even one of them was in college, and they used to complain that I had another smelly magazine that had just showed up. It was probably sent from someone's garage or basement. But these photographs came online. I don't think I paid more than $4 or $5.99 for any of them. There were press photographs that were in newspaper files, and then when newspapers get rid of their files, they seem to end up with collectors and resellers and that sort of thing. So these are mostly marked up with grease pencils like this. On the back is usually slapped the caption that was in the newspaper. Sometimes you know what newspaper it was in. But this is a 1945 picture from Thule, Greenland. That's the far northwestern corner. And it's entitled Greenland Home Life. The man, the boy, and his playful husky pups bask in August sunshine behind their sod house. So this was one of the traditional dwellings for the Inuit there because sod is such a great insulator. It's a native material like this. Clearly not everything in here is native, right? But this was a traditional house that the US military forced many of the Greenlanders in Northwest Greenland out of their traditional houses and lands and put them in prefabricated buildings that couldn't stand up to 100-mile-an-hour windstorms. So there's a tragedy of a group of people who were moved for the biggest US military base. This one is much more subtle, but I also think much more disturbing, and I think it plays to the time we're in right now really well. I'm just going to read you the caption. You can think about what it means. This is in East Greenland. It was at one of the weather stations the US established after the Nazis were removed. It's a 1945 picture. And this is literally the caption on the back of the photo as released by the Defense Department. So this was a US Defense Department photo. Kistamaki has learned about Americans from Yank service personnel stationed in Greenland. And here she paints her sentiments about the US on a rock near her home. She uses the typical American expression, okay, which in any language means she liked it a lot. There's the okay, USA. So the longer I stare at this photo, the more disturbing I find it, in terms of the implications of what it means for how we related to the native peoples of Greenland, and just this, I think, sort of incredible power differential, and I see that coming again in the last couple of months. And so I've looked at this photograph a lot in the last few months. All right, so Bader realized that ice could hold a record of climate. And that was crucial because the 1940s were actually a warm period when there was a lot of melting of glaciers, and there were a lot of scientists and military folks kind of going, this is a problem. Why are the glaciers melting? Why are they retreating? How are we going to operate on snow if it's slushy and melted? So he went to a place called the Juneau Ice Field, and this is the drilling on the Juneau Ice Field. They had an 8mm camera with them, and so you're going to see here the picture of the first ever US Ice Core. There it is. They spent a week or two drilling on the Juneau Ice Field. It was summer, it was wet, it was warm, and this is fun. The guy carrying the core here into their trench where they keep their cores frozen turned out to be the man who dated most of the US Apollo moon rocks. One of the most famous geologists for dating rocks out there, a guy named Jerry Wasserberg. He was a field assistant on the ice here in 1950, and the connection that I have with him is my PhD advisor worked with this guy for years. Never knew that he went to work on ice. Thought all he ever did was rocks. And I sent him this clip, and I got this amazing email back saying, that can't be real, you know. But I know that's Jerry, so. Bader then waited a couple years, and then went to Greenland in 1956. And we're not going to hear this, so I'm going to turn that down. But this is the Army drilling in Greenland in 1956. And they brought a drill crew from the mainland, they brought a drill rig from the mainland, and they tried to drill ice, and it did not go very well. This is like you'd be drilling rock in Vermont for a water well. But the technology just was not up to that. So the first year they got very little, and the second year they did a lot better. But they're drilling inside a trench they've cut in the ice using a big snowplow. It's about 30 feet deep, and that gave them protection. So they learned that it was possible to spend months drilling ice in a relatively comfortable environment. The technology just wasn't right to do that. And they did this again, 56, 57. So Bader kept thinking. He was an idea person who hired a lot of really good engineers to work with him. And he hired these engineers to help the US figure out what to do in the Arctic. And these are just a couple, this is actually Bader's citizenship application. But you'll see a couple things that he did. He figured out, and his engineers figured out how to do airdrops. They helped create vehicles like this to move through the snow. And they figured out how to do ice drilling a whole lot better, eventually. But they're real, I'm going to skip that because we don't have sound, unfortunately. But in 1953, they started thinking about putting people in the ice, influenced by a French expedition from late 1940s, who did hand-shoveled tunnels like the Germans did, and certainly influenced by the Germans, but because this was the American military, they were not hand-shoveling anything. They built 2 bases that look like this. The rumor or the story is this came from talking to the French in a discussion with a lot of alcohol late at night about the idea of submarines being able to resist the pressure of being squeezed in the deep ocean. And could they do the same thing in the ice by building tunnels that were essentially pressure hulls like a submarine? So these were nicknamed sewer pipes, but they are corrugated steel bolted together in 18-foot diameter tubes. And into those tubes, they put prefab buildings. And they buried this, well, they buried it about halfway, and then the next year or two, the snow buried it anyway. And they had escape hatches here for when these would get buried. They had generators, all these things. They called them Site 1 and Site 2. This is what they look like on the inside. There's some guys carrying a box. They had electric generators, they had lights, they had showers, they melted water. This was all part of the red paranoia of the Cold War. And I just pulled what I thought were some interesting covers from magazines and advertisements at the time, but this is the red iceberg that's about to sink the USA. And of course there's the Soviet Union, but then there's Poland and Hungary and China, and again it sort of echoes today a little too closely. And then this horrible propaganda that if Russia should win, American women would be smashed under the boots of Russian soldiers. And then this, which was another eBay find for me, a magazine called Real, the exciting magazine for men. It lasted somewhere to like the late 50s, and then it doesn't exist anymore. This, I believe, is 1955, and here's the cover, and there's a rugged man clearly there. We've built a military miracle in the Arctic, our secret base under the polar ice, and it's an exclusive. So this must be the manly thing to do. This was the most informative article I found out about these bases anywhere. It told so much about their construction and their operation, even better than the 1,700 pages of declassified material I got sent from the Air Force History Museum, which talked about how the men hated the smell of diesel fuel and that their pancakes wouldn't rise and those sorts of things. But this was an amazing read, to read this article. And it was also really well illustrated. So they had these incredible sketches, but they didn't tell you where these things were. The only thing about them that was secret was their location. This is bragging that we are doing something, and certainly they're doing this thinking the Soviet Union is listening. So here's the delivery vehicle for food and supplies, ping pong, couch, bunk rooms, heat, all that sort of thing. They said these were weather stations in the US newspapers. It turns out that the weather stations had this, which is called a radome. These were actually radars looking for bombers and missiles coming from the Soviet Union over the top. There were some big radar installations in Greenland, but they had some gaps, and these were called gap fillers. So they were not what they were purported to be. They were taking weather measurements, and you can still get the weather measurements online unless NOAA has been forced to take that site down. But you can get daily temperatures for 3 years from these stations in Greenland, which was amazing at the time. But they were military assets. So once they had figured out that they could put these big tubes, metal tubes under the ice, they went really big. But there were 2 things that got in their way. The metal tubes were heavy and expensive and difficult to construct. They took a lot of time, they took a lot of materials, and they used a lot of fuel. to heat these things and to melt water. So they wanted to build a new camp out of native materials. And what do you have in Greenland for native materials? You have snow and ice. And they wanted to power it with a nuclear reactor. And that became Camp Century. So this is Popular Science, and this is the spread on the first page of this article. Published as the camp is being built. It had a 1,000-foot main street here. It had, I think, 23 side tunnels, all these prefab buildings that went along with it. And it's 800 miles from the North Pole. This is the plan view map. There's the 1,000-foot main street. Here are the quarters, the mess hall, the 50-person latrine, the 100-person latrine, the science and research tent, tramps here. Here's the quarters, more quarters, and this is the nuclear reactor up here. The French had a much better view on this. This is from a young adult French magazine, and much more of an artistic rendition. But they show you how the camp was built with these giant snowplows digging trenches, multiple passes, and then they put together prefab buildings. They would cover the trench roofs with metal like this, and then they would spray snow on top of those metal forms. The snow would harden, they'd pull the metal forms out. So the men were living inside these trenches, inside the snow. Of course, it's quite dark in there, but they had all sorts of ways to get there. They could get there by a helicopter, or they could get there by an airplane, but most of them came by sleds over the ice, pulled by tractors. Took 2 to 3 days to get across the ice, 138 miles. This inspired things away from Camp Century. This is a futurist who published in the Sunday newspapers between 1958 and 1963, imagining what the world might look like. And this is his imagination of cities under the ice based on Camp Century. So they would have a nuclear power plant there. There'd be a huge cavern in the ice. There'd be ventilated, solid ice would be there. There'd be monorails and funky Jetson-looking cars, all inside the ice sheet. I think I was probably too young, because I was born in '61, to ever read one of these. And this one is actually from 1960. But it's just an amazing thing that culturally, this military base permeated our Sunday comic strips. It also permeated the editorial pages. And here's an editorial from a Knoxville paper when the camp was announced in 1959 that gets just about everything wrong, but I'm suspecting most of it is sarcastic. But there is an Inuit on snowshoes in the middle of the ice sheet. That does not happen. A tunnel like this with mountains. There's no mountains in the middle of the ice sheet. It's dead flat out there. And there's balmy Camp Century with atomic heat and a bikini-clad woman. There were no women at the camp. There are rumors of 2 women. I could go into the stories in the book a bit, but there's no substantiated visit of a woman to that camp, just these stories and rumors. As I said, there were big tractors that brought things in. This particular tractor is bringing in the portable nuclear power plant. It was modular. It was built in Schenectady, New York. They brought in a crane to put it together, and put it together they did. And it ran for over 2 years. This is the control room on the first day of startup. These are 2 Boy Scouts. Publicity stunt by both the US and the Danes. The far Boy Scout is the American Boy Scout. The closer one is the Danish Boy Scout. Huge competitive selection process to spend 5 months living with a bunch of GIs under the ice. They came back. They were on all sorts of television shows and newspapers. And then a couple years ago, the translation of the Danish Boy Scouts diary was made public. And it turns out, instead of being such a wonderful experience, they were miserable. They complained about the guys drinking too much, smoking too much, talking about women all the time. It was not where you wanted to be at age 18 under an ice cap for 5 months. So the reactor went in, and 2 years later, the reactor came out. Ostensibly, so it could go to McMurdo in Antarctica, but really because there were worries about the naval reactors and submarines getting brittle because of the radioactivity within them. And so they took out the Camp Century reactor as a way to see how brittle the metal had gotten that contained the reactor. This guy, by the name of Joseph Franklin, 31 years old at the time, had a master's in nuclear engineering from MIT, was, I think, an Army colonel at that point, was assigned to decommission the reactor at Camp Century. Nobody had ever decommissioned a working reactor in 1963. So he's not only decommissions it, he does it in the middle of an ice sheet with a small group of men. They remove the fuel rods from the core and they put it in this lead-lined cask, and it's sent across the ice. They leave the reactor for the winter so that many of the radioactive elements could decay, the short-lived ones that are extremely radioactive. They come back the next year and they take the rest of the reactor out in about a 6-week period. It's just a stunning story of technology. He went on to become a general, teach at West Point, and die of multiple cancers in his mid-80s, which he attributed to the amount of radiation that he, as the commander, took because he didn't want to expose his men to it. It's hard to know if that's actually the cause, but amazing writings that he did. And the fun fact is he went to the competitive school, the one I went to for high school. And it turns out that I went to school with his nephew. And so there was this fun connection at about 2 in the morning when I'm doing this research of like, wait, I know that name. So this would have been life inside Camp Century. So the Army sent a great film crew up. There's pristine 16mm footage that we had digitized. So you can see what it would look like walking down Main Street. And I can tell you that's really early because there's no frost on here. It's like the inside of your freezer. As you look at pictures that get older and older, it gets frostier and frostier. The Army advertised that there were unlimited showers for their men there because they had unlimited hot water because they had a nuclear reactor to make the hot water. So you're there, it could be minus 50 degrees Fahrenheit on the surface of the ice sheet, and you're shaving shirtless in a latrine inside the ice sheet. It's kind of crazy. They kept the place at 72 degrees. They had a full hospital there for minor surgeries and x-rays and all that. 200 men could be bunked in that camp. Again, I showed you the inside diagram from Popular Science. This is the cover. And this is one of those plows doing its thing. And they would take the plow multiple passes through the trench. And that's how they built all the trenches in basically one summer. That video will show you the plow in action. These plows were used in the Swiss Alps to clear avalanches. They have to be a Bader thing working in the Swiss Alps to get them there. Here's one of those prefab buildings. This is a National Geographic photo inside those trenches. And they had a full commissary. They had a full dining hall, mess hall, place to cook. The men complained there were too many steaks served and too much turkey. They got 1.5 times the normal rations because it was cold. They served dinner in the morning and dinner at night for people who were working night shift. So 24-hour food. I think 4 meals a day were served there. But what we're interested in is the drilling and this ice core. And so this is the drill trench right there. And again, they were sheltered from the wind, and they could do so much in there without that wind and cold. And this is that core that I started the talk with. So the core was lost until 2018, and I got really lucky. I got a phone call from a Danish colleague who said, a small group of us are meeting to look at cores from the bottom of ice sheets in Greenland. She didn't tell me it was the Camp Century core. And Christine was there with me when we did this, and they took us to their brand new freezer. And we walked in the brand new freezer, and we're looking, this freezer's the size of a big grocery store, to put it in context. And they hadn't even put their shelves up yet, so we're looking at all these boxes on the floor, and the curator says, come on over to this corner to a couple of us. And he opens up this box, and these are pieces of that core having been sliced up into about 4-inch sections on there. And until that moment, I didn't think the core existed. And that's me. It's minus 27 Celsius in the freezer. I'm wearing sort of March clothes or April clothes there. And we stayed as long as we could until we were shivering. Original box from Buffalo that the core was shipped in. These are 3 graduate students who have been working with me the last couple of years to understand this core. And that's in the freezer in Denmark. We got them to send us 2 samples. You could hold this sample in your hand, not that you would want to, it's that small. And we melted those samples. And because so many people wanted the material from those samples, we filtered each one of them. And we saved everything. We didn't let anything go down the drain. See if I can play that video again for you. I want you to watch this time as I'm playing it and look for things that are floating on the surface there. You see the little black floaties on top there? I looked at that. It's the middle of July. It's more humid than it was today. And I had spent my early part of my career looking at sediments from lakes. And when we wanted to find bits of plants to use radiocarbon to date, we would set them in a bin like this, stir them up, and go and have lunch. And the bits of plant parts would float to the surface, and the sand would sink to the bottom. And I looked at the guy I was working with, and I said, I think there are fossils in here. And he looked back, and he gave the string of expletives that I will not repeat to you all, about how crazy I was, and maybe it was heat stroke, and I'd been out too much that day. And so we then took that water, and as I say, we filtered it here. And this is a filter in the lab. It's a couple inches across. And look for the arrows that come in here. Each one of those arrows is pointing to a small piece of organic material. And I say organic material because we didn't know yet what it was, but just these little bits until we popped it under the microscope. And so what do you see in there? I'm presuming none of you are paleobotanists trained in that, but what do you see when you look at that? Seeds. What else? What's right in the center? Yeah. I'd call it a twig. It's about a quarter-inch long, not very long. It's less than a centimeter long. But this is the view with Drew's cell phone down the tube of the microscope. We didn't even have a microscope camera in there then. We just looked down that tube. And this is a moss over here, and there's some bits of seeds and then the wood. We were absolutely stunned. We had no idea that underneath nearly a mile of ice would be fossils that represent tundra. And this literally was a frozen ecosystem under the ice. And we spent the rest of the afternoon. I've never had a spine-tingling moment in my life doing science. This was a spine-tingling moment. And all we could do was look at each other and smile. And it was crazy. In fact, we dragged a bunch of high school students for a program Christine was running called the Governor's Institute in. And we're jumping up and down because we were teaching in that program about how exciting this is. And they're looking at us like, you guys are weird, you know. But then they looked down the microscope and they're like, that's cool. As we kept looking, and this is Hallie Mastro, one of the graduate students I showed you, it's her photograph. This is a midge. This is the kind of thing in Greenland that flies around your ears and buzzes, doesn't bite you. Just really annoying, almost perfectly preserved here. So we have plants, we have fungus, we have insects, all from the bottom of that core. And now we know from some geologic dating that these are 400,000 years old. That's a long time ago, right? So what Hallie has done here, which I really love, is she's taken the fossil, and then she's taken a picture of what that would look like today if you were out walking around on the tundra. So this is birch, but it's not the birch like we think of here. It's a birch that's about that tall and grows along the ground and trips you if you put your foot in it the wrong way. And so we know there was this ground-hugging birch there. Anybody know what this plant is? People grow them here. Ours is coming up in our front yard right now, but we're in Burlington. It's poppy. It's an Arctic poppy. We planted one that I bought from gardeners last week called an Icelandic poppy, but very similar. That's a poppy seed. So that's the seed Hallie found in the sediment from below the ice, and this is the plant today in Greenland, the Arctic poppy. So the cool thing I think about being a paleobotanist is you look at that, but your brain tells you this. It's this ability to see landscapes that don't exist. And so what Hallie and the people she was working with at Columbia suggested is that in fact, when we looked at all the different seeds and pieces of wood, the landscape probably looked something like that. It didn't have a helicopter on it. But it was rocky, it had wet spots, it had dry spots, it had bare soil, it had vegetation, it had permafrost, frozen ground, and then it probably had some ice and snowbanks around. The plants tell us that. They tell us what the landscape looked like. So now we know that Camp Century, 400,000 years ago, had no ice. There's another core in the center of Greenland where we found very much the same fossils. We don't have the date down well for that, but within the last million years, there was no ice here. Within 400,000 years, there was no ice here. If these two sites have no ice, 95% of Greenland has no ice. We know that from the people who make mathematical models of ice sheets. So this is what it looks like today. We lose 50% of the ice. Camp Century would be out, but not the center. 90% of the ice might get the center out. 95% of the ice certainly gets the center of Greenland out. That's really important for us as a society in the next decades to centuries. So this is a kind of complicated diagram. I'm going to go through it and explain it to you. But it's a really critical one to understand. So this is today, 125,000 years ago, 400,000 years ago, 3 million years ago. These little symbols indicate the amount of ice on Greenland and Antarctica. The red says that ice went away. So 125,000 years ago, we think about a quarter of the ice on Greenland went away. And we think about 3/4 of the ice on Greenland went away 400,000 years ago. This is a diagram by a woman named Andrea Dutton, who's now at the University of Wisconsin. So she's thinking about what's left on the ice. She's also thinking about carbon dioxide levels. So in 1890, our carbon dioxide level was here, about 300 parts per million. That's about the same as it was 125,000 years ago and about the same as it was 400,000 years ago. What have we done to the carbon dioxide levels in the last 100 years? Up and up and up. So when she made this diagram in 2014, it was around 400 ppm. In 2024, when I augmented this diagram, it's about 420. It's a little above that right now. So we are 1.5 times where we were when humans started messing with the climate sort of big time in the late 1800s. If we look at when a quarter of Greenland melted, 125,000 years ago, what was the carbon dioxide level? It was low. 400,000 years ago, low. 3 million years ago, it was about where we have pushed it to today. And here's the kicker. This is the estimate of sea level rise. And that's not in feet, that's in meters. So we go back 3 million years ago, sea level could have been as high as 40 meters, 45 meters above where it is today, or it could have been just 6 meters higher. The trend is much more toward this high end. Temperature was quite warm, 2 to 3 degrees Celsius warmer than today, pre-industrial. But we now have just blown through the Paris 1.5 degrees Celsius limit. So we are toying with temperatures like this. When do our fossils come? Right there. So Greenland melted on its own with carbon dioxide levels much lower than today. That raised sea level between 6 and 13 meters. Convert that to feet, and you're talking 20 to 40 feet. Now I'm going to try something with you that I try with my 300-person class, which is, if you haven't already, close your eyes and imagine your favorite beach, right? And that beach has to be on the ocean somewhere. And now imagine that beach if the Greenland ice sheet melts and about 24 feet of water are going to be on the beach. So let's call it 25 feet of water. And then imagine how you got to the beach, the parking lot, the hot dog stand, all those things. You can open your eyes now. What happens to your beach with 25 feet of water?
It's swept away.
It's gone away, right? That's the guttural check on this, that if we lose Greenland's ice, all those places that you value, you have memories. I grew up going to Cape Cod in the summer, and I imagine 25 feet of water on top of the beach. The Cape Cod is lapping up on the cliffs where the stairs are, right? And Route 6 on Cape Cod is going to be cut place after place after place with 25 feet of water. If we let the ice sheet melt, that's what we're looking at. All right, I want to close by bringing this to the kind of present day. This is a diagram that I really like. That this came off a New York Times website, but I think Noah may have done it the first time. These are average temperatures per month of the year. So every time you go around here, that's a year. The temperature, sort of long-term average, is here at 0. If temperatures drop, they go here. If temperatures rise, they go here. And this is going to trace climate change since 1966. Watch what happens. Isn't that cool? It's awful, but it's cool from a graphic point of view, because not only do the rings get bigger, they get redder, which means it gets hotter. So this is 2022, and we are well above 1 degree Celsius in warming, and now we're pushing 1.5 in just those few years since then. So again, let me back up and play this one more time for you, now that you know how it works. Okay, and there we go through time. So for anyone who still thinks the climate is not changing, just look at this graph. Every month of the year is getting warmer on average here. Let's compare that to what we know has happened in the past, right? So I was talking about that magic 400,000 years here. We know that the Earth cycles between glacial times and interglacial. So that's cold, warm, cold, warm, cold, warm, cold, warm. It does it on a pulse beat of about 100,000 years. And that's driven by the orbit of the Earth around the sun and the tilt of the Earth and all those sorts of things. Between an interglacial warm period like we're in right now, and we have been for 10,000 years, and the cold period, in the Arctic, the temperature difference is about 6 degrees Celsius. And that translates to about 10 degrees, a little more than 10 degrees Fahrenheit. And that's what you should expect as you go slowly into a glacial period, and then you come out really quickly to an interglacial and slowly back to a glacial. The prediction by 2100 in the Arctic is we are going to warm as much as we cooled from the last interglacial to the glacial. So humans in 100 years are going to replicate what takes nature thousands to tens of thousands of years of temperature change. That magnitude is headed for the Arctic. The Arctic warms about 3 times faster than the rest of the planet. Not good for Greenland. And that's just what is happening. So the ice sheet's melting. And it's melting rapidly, and we can measure that melt really accurately. So a little bit of history before we finish up. This is Life magazine 1962. And this is the Taku Glacier where Bader did his drilling. He was about 15 miles, 20 miles up glacier of this. This is where the glacier meets the fjord, and the ice calves off. And ENCO, I have learned, is the predecessor of ESSO, is the predecessor of Exxon. And this is an advertisement, 2-page spread they did in Life, and I was a year old, so I was running around in diapers at that point. Each day, Humble Oil supplies enough energy to melt 7 million tons of glacier. So they are bragging about their ability to melt ice, and it even gets better. The giant glacier has remained unmelted for centuries. Yet petroleum energy Humble supplies, if converted to heat, could melt it at the rate of 80 tons each second, exclamation point. Things have changed, right? Oil companies do not brag about melting ice sheets anymore. But of course, melting ice sheets lift all boats, which is a play from a Washington Post cartoonist. There's the city that the melting ice sheet is putting underwater. And there's the ice sheet weeping. Melt Greenland's ice and sea level rise over 25 feet, about 25 feet. So I'm arguing here, and I have argued in a couple pieces I've written, that sea level is what is really most important about Greenland. And ice related to that. 1900 to 2020, this is the rise of global sea level. Those units are millimeters, so 200 millimeters is not a whole lot so far. But you'll notice that curve is steepening.
Yeah.
And the result is the melting of mountain glaciers, which started melting early, Greenland's ice sheet, now Antarctic's ice sheet, and in fact we're warming up the ocean so much that the water is expanding because it's getting hotter. And there's all of those are contributing to sea level rise. If we look out in the future, the rise is fairly uncertain because we don't know the feedbacks that are involved in destroying ice sheets very well. But the best estimates are by 2050, and if I'm lucky, I'll still be around in 2050, 7 to 10 more inches of sea level rise. Now, you say that might not be that much, but what if that's the difference between flooding the subways in New York and not flooding the subways in New York? Or what if that 7 inches is the extra 7 inches that floods your house and fills your basement? The real kicker, though, is sort of our children's children, 31 to 69 inches by 2100. That's almost my height by 2100. That's a difference. That's the end of your hot dog stand on the beach, sort of thing. And 6% of the US population live within 7 feet of sea level, 6.5 feet of sea level. So this is not a small number of people who would be impacted just in the US. It's far more frightening when you think internationally. If we melt all of Greenland, if 25 feet melts, 500 million people will either not have a place to work, not have a place to live, or not have a place to farm. The economists in today's dollars predict that's many trillions to tens of trillions of dollars of net loss. So there's both the ethical reason to preserve the ice, there's the practical reason to preserve the ice, and there's a financial reason to preserve the ice. Because it is going to cost us in all kinds of ways. That diagram is what I was trying to get you in some ways to imagine in your head. People swimming today, sea level at 2030, sea level at 2050. You almost need to see this to convince people that it actually matters that when sea level rises and what's going to happen to us. So, very famous guy, Wally Broker. He was an oceanographer, he was a curmudgeon, and he is best known for this quote: "Climate is an angry beast and we are poking at it with sticks." We know now that Greenland was 90% ice-free in the last million years, with CO2 levels much lower than they are today. So I am taking the liberty, since Wally passed away 6 years ago, of changing his quote a little bit, Xing out climate and putting Greenland as an angry beast, and we're poking at it with sticks. So I added this to my last 2 talks I've done because I need to reflect on what's going on in the world right now. And I don't mean any political offense here. I want to just point out that Greenland matters, but it may not matter in the way our president thinks. So that's Costco. That's the president. And for those in the back who can't read this, he's saying, "Never fails. I went in for some cheap eggs and came out with a bunch of stuff I really didn't need." Panama, Greenland, Mexico, Canada on there. Or welcome to Mara Igloo in Greenland. Or this one's poking fun advance. We are go for Greenland takeover in the yellow snow out here, signal leak. And my favorite, this is the New Yorker. 3 reasons that President Trump wants to buy Greenland. Thinks it's green, couldn't think of what else to get Melania for her birthday, and huge rebranding opportunity. One of my colleagues sent me this, and I'm not sure I believe any of these, although they're funny to laugh at. This is very geographic. So we are a product of the maps we look at, and our conceptions of the product, in many ways, are maps we look at. Most of our maps are something called a Mercator projection, which takes a sphere and flattens it onto your tablecloth. But by doing that, deforms the size or the shape of land masses. So the white here is the Mercator projection. The purplish is an equal area projection that deforms the shape but maintains the size, relative sizes. And you'll notice if you're at the equator, they agree perfectly. And as you get to high latitudes, there's a really big difference. So the real size of Greenland in comparison to everything else is purple, and the white is what it shows up on the Mercator projection. There's Russia. There's Russia. There's Canada, made quite small. Alaska made small. Even the US shrinks in this. This friend said basically, I actually think Trump just likes bright, shiny objects. Big, bright, shiny objects. And Greenland, in fact, is bright and shiny, and it's important it's bright and shiny because it reflects the solar energy coming in and keeps the Earth cool. It is nowhere near as big as it appears on a map. So I have no idea what the truth is, but I think it's really important, and one of the things I've decided, because I've spent 5 years working on this, I've thought about Greenland, is to essentially open my mouth. I'm also 60-something, I'm a tenured full professor, I have the privilege of being able to talk and push back in various ways. So I don't do it with the comics, but I've been doing it with my pen in some ways. And I thought these may or may not interest you all, but this is a piece that I published in early February. No, it's late January. So not long after the inauguration. And it's that same hypothesis that I've put in front of you today. We need Greenland, but not in the way that Trump thinks. We need Greenland because of its ice. We don't need it for its military strategic value. We don't need it for its economic minerals. We need it for its ice. This is free online. It's a magazine called Undark, so you can pretty easily find it. And I went from there back to my training, writing for another online magazine called The Conversation, which I strongly recommend. They do sort of 1,000-word summaries of pertinent topics in all disciplines, usually written by academics or experts in the field. And they asked me to write one about, does it make any sense to extract minerals from Greenland? And this goes back to my training in geologic hazards and landslides and geomorphology, the surface of the Earth. So this is another one that might be of interest. But the one that I'm actually most interested and proud of is one that responds to this. And I was teaching this in my climate class last year along with a colleague that I teach with. And these are data from the Yale Climate Center. So Yale does a lot of surveys of people's opinions on climate. And I'll narrate this for you. This is 2008, it's 2023. Blue indicates people who are on the liberal side of the political spectrum, and red indicates people who are on the conservative side. And this is a partisan gap on climate action, 100%, 0%. Voters who think global warming should be high or very high priority for the next president and Congress. So we have a gap of, what, 70 percentage points between people who identify as conservative and people who identify as liberal. Yet, climate change has no gap. The weather and the climate affect everyone. The flooding affects everyone. And so this actually really bothers me when I teach and when I interact, that we have built this partisan divide that does not and should not be there because humans of every political stripe are going to suffer as the climate changes. And the best comic strip for this is right here, right? I mean, it's a cartoon, but you're going to sweat no matter which party you belong to when it's hot. And when the rivers flood, no matter which political party you belong to in Montpelier, you're going to get your feet wet. And in Burlington, when the lake rises, right? So all of these various things, and landslides hit, do not depend on your political affiliation. So the last piece I wrote, which actually has gotten the most interest, is digging back into my history, and that the military in the United States cared about climate change starting in the 40s, and they have continued to care to this day. And they are taking action, not in a political way, they're taking action because their strategic readiness requires they respond to changing climate. And they need to understand if they're going to be 500 million migrants, because it is going to be a threat multiplier. So this is the last piece I wrote, and I really tried hard to stay apolitical and to try to figure out how to bridge this gap. And if I have anything to leave you all with, it's to figure out how to bridge this gap, because it is the only way we will save the ice, despite the funny political cartoons. We need to start talking to people who think differently than we do and finding a way to do that. And so, yeah, a couple resources if you want to learn more about what we're doing. Campcentury.org is our science website if you want to see the science we're doing. paulbierman.net is my personal website. And then our laboratory at UVM is uvm.edu/Cosmolab. And that's the book. The book is here, and the intent of the book also in many ways was to try to bring the science that I've outlined here today and the history I've outlined here today in a way that, how should I put this? The scientists who read it say that I don't do the science rigorously enough, and other people who read it say, wow, there's a lot of science in there. So I've somehow managed to get both sides not completely happy, but I think that's exactly what I wanted to do. And we have some copies of the book if you want to buy one from us here, or you can buy it in your local bookstore if you'd like that. The paperback is coming out, I think, the end of the summer, but we have the hardbacks right now. So thank you for having me. 20 pages dedicated to that in here. I'll give you the quick cliff notes on that. The ice was first in Krell in Hanover, New Hampshire. Then it was transferred to Buffalo with the curator, that fellow named Chet Langway. The United States National Science Foundation supported a set of freezers for him to keep the ice in for 20 years. That's unusual. Usually they support facilities for 10 years, 15, and then moves on. At year 20, they decided to recompete the facility, which meant lots of people could propose. And there was a lot of complaining in the community because this man in particular liked to hoard his ice, he liked to keep his ice, and he didn't share well with others. And the community said, the ice needs to be someplace where it's a level playing field for any of you who want to get the ice to do science. They moved the ice to Denver, and he was contractually obligated to send everything. The bottom of 2 ice cores never made it. And they were just assumed lost. It turns out, depends on who you ask in Denmark and the States, he threatened to throw the ice in Lake Erie and the Danes came to get it, or the Danes wanted it, his best colleagues were in Europe. In the end, none of it matters, because the Danes did a spectacular job of keeping that ice frozen from 1994 until today. And the amazing thing is that the core is drilled in 1966 and none of the material we worked on has melted since. Think about how hard it is to keep the freezer in your house running for 5 years, power outages, you name it. This stuff stayed frozen the whole time. So it's a really interesting story. I think it's a story of science competitiveness and of a resistance to opening up a field to newcomers. But in the end, you know, it's a blessing, because in 1966, had they ripped apart this frozen soil, hardly any of the techniques we have today to understand it. And so the whole thing's preserved. We cut it in half. Half of it came back to Vermont. We've melted those halves and transferred them across the world. But the other half is still sitting in a freezer in Copenhagen for 20 or 30 or 40 years from now, when somebody else has even better techniques than we have today to understand it. And that's how science should work, right? So it had a happy ending.
I noticed in the films that they were dealing with the core samples, that they were handling them with their bare hands.
They absolutely were.
So contaminating them.
Yeah, they didn't know better at the time. We have addressed that in several ways. For the really sensitive analyses we do, we certainly work with gloves, we work clean, but we cut away the outsides, and we use those for things where the contamination wouldn't matter, and we save the absolute center for the material that's very sensitive. Does that protect us completely? Probably not. They also drilled using Arctic diesel fuel as a drilling fluid. So here, if you're drilling a water well, they might use kind of mud to drill with, and the chips would come up. There, they couldn't use liquid because they're in ice, right? They couldn't use water-based, so they had to use this Arctic diesel thinned with trichloroethylene, which is dry cleaning fluid. So opened that first core I showed you in our lab, and we reeled from the smell of diesel that came off that frozen sediment, and we immediately put it in a fume hood where it was ventilated. So yeah, we know we have contamination. There's not much we can do about it. But again, by doing the core cutting right, we've minimized the effects. And we know for most of what we're doing, we know what diesel fuel looks like. So we know the influence of the diesel fuel, say, on the organic analyses we're doing in the core. But the diesel fuel didn't put the fossils there. Other questions? Yeah.
When you showed the layers of winter, summer, and those are fairly modern ones, would those have pollen and other organic or, significant?
Not much, because you have to get it to the middle of the ice sheet. So there are small bits of organic material that blow in, but mostly they're things that come out of the atmosphere. So ice cores are a marvelous recorder of volcanoes, because volcanoes spew not only volcanic ash, little bits of rock. So like the Icelandic eruptions in Greenland, you can actually see gray bands from the ash coming off of Iceland. But the huge volcanoes, the Indonesian volcanoes, the Yellowstone-style volcanoes, when those blow up, they put a lot of sulfur. Mount Pinatubo did this, into the atmosphere. And that sulfur rains out as basically sulfuric acid onto the ice sheet. And so what they'll do is measure two things. They'll measure the acidity of the ice, and they'll measure the conductivity of electricity. And that will tell the people working on the ice itself how much of these things are falling out of the atmosphere. Other thing that they've measured in the ice cores, and it's one of my all-time favorite things, is lead. And they've taken that back well past Roman times. So if you're in Europe and you're smelting ores, you're often smelting ores for silver or for lead. They're doing it outside in big open piles, and the smoke is going up into the atmosphere. It's being wafted north to Greenland. We have very high sensitivity instruments for measuring lead. And they can actually track the levels of lead in the ice core, and there are papers that attribute that to either historical issues in the Roman Empire, the fall of the Roman Empire, and when there's a political collapse, people don't need as much silver and lead, and so the mines stop and the smelting stops and the lead levels in Greenland drop. Same thing happened during the big plagues. So they can see some of the Roman plagues in the ice core. Now, the anthropologists get a little upset about this sort of determinism, and the natural scientists think it's the coolest thing. But the best paper is one that's got both historians and natural scientists on it together. And it's amazing that you could take a piece of clear ice and relate it to what was happening in Europe and the Roman world and the Greek world at the time. So, yes?
Your graphs show huge changes in the sea level over time, presumably because the angle of the Earth to the sun, or perhaps the temperature of the sun. I mean, there are all kinds of non-human variables. Has anybody tried to study that?
Absolutely. So the question was, there are big changes in the Earth's average temperature, and therefore the sea level and the amount of ice on Earth over time, most of which is on, for the last 1,000,000 years, this 100,000-year cycle of up and down. And that's determined by the shape of the Earth's orbit and the tilt of the Earth. We know that the sun has put out about the same amount of energy. There's not much change in what the sun does. It's, I suppose, why they call it the solar constant. It's pretty constant. But we know on this 100,000-year cycle, the Earth gets cold and the Earth gets warm. The difference with humans is the rate at which we are changing things and the means by which we are doing it. So we're injecting this huge amount of carbon dioxide into the atmosphere, and we're changing the energy balance of Earth because of that. And we're not doing it on a 100,000-year time scale, we're doing it on a 100-year time scale. And that makes it a really difficult process to accurately predict and understand, because nature has never worked this fast. So we're trying to deal with this just, some people call it the great acceleration. Population, energy use, emissions, the rate at which we change Earth's surface have all, every curve you look at goes like this, and the last 100 years goes straight up. So yeah, and people have looked at it, and there is no way to match the measured records without the human-induced carbon dioxide. None of the natural, And 20 years ago, that was a not unreasonable debate, and it's all out the window at this point. And I think what's interesting is you watch the climate, what we thought it was climate denialism when I started teaching 30 years ago. That traditional climate denialism is gone. There's hardly anybody who's saying the climate isn't changing. Now the response is, oh, it ain't that bad, or we can't afford to do anything about it, or, fossil fuels make us all richer. And I mean, we could spend an hour and we could chat about this, but the end result is I think almost everyone in the world acknowledges that climate change is real at this point. The question is how, if, and when do we respond? Larry?
Yeah. Basically there's a cut in these underground tunnels. There's a cut through the ice. Has anybody looked at the structure of the ice relative to the west, where the toe of the ice is maybe retreating? And I don't know, maybe it's too far from the western side of Greenland to see some effect, and you do some kind of prediction based on the structural change in the ice and what's going on.
Yeah, so the ice cores are drilled typically at the highest point of ice sheets where the snow falls, and then the ice itself deforms over time. It changes shape over time because of its own weight. So we think of ice as solid, right? You hit it with a hammer and it breaks. But in fact, if you push on ice slowly enough and long enough, it deforms like, I don't know how to describe it, it's not thick honey, it's even thicker than that. But it will flow. And so the ice flows down and then it flows out toward the coast. The reason you tend to drill at the center is you want your layer cake. By the time things start flowing out to the side, they're very badly deformed and much harder to interpret. So most of the work on ice is done at the divides or near the divides, up high.
Where these haven't seen any change, given that they were.
Oh, but they have.
Okay.
Yeah, and one of the things they've seen at the high summit locations is an increase in summer rainfall events. So I could talk for hours about this. I could have put that graph up. But in the last 20 years, the frequency of rainfall events has exploded at 10,000 feet on the top of the ice sheet. I think there are 4 in the last 20 years, and they're typically about 1 every 100 to few hundred years before that. So it's just getting warm enough that now it's raining on the top of the ice sheet. Right? And that doesn't typically happen. So what we're going to see, unless we change our ways, is we're going to see the parts of the ice sheet that melt every summer getting larger. We're going to see the ice sheet start to lower. And there'll be a point at which, in the summer, it is so warm that there is melt over the entire ice sheet. When the ice sheet gets warmer and gets smaller, it actually, the way to describe this, it lowers in the atmosphere. So let's say the ice sheet's the height of Mansfield. You know you climb up Mount Mansfield, it gets cold. The ice sheet shrinks by half, and now you're only halfway up Mansfield, it's not as cold. The ice sheet shrinks by half again. You get to a certain place where you can't maintain an ice sheet anymore because it's too warm. All your snow melts away in the summer. And that's the we call it tipping point, or a point of no return. So if we let Greenland get small enough, it's just going to disappear on its own. And that's part of the urgency of dealing with the melting of ice sheets, not tomorrow, and not even 4 years from now. We may have a few decades. The sooner we do it, the sooner we decarbonize, the sooner we change our energy system, the cheaper it's going to be for us to do. And the easier it's going to be. We're not going to be pulling as much carbon dioxide out of the atmosphere. We're not going to be fighting as much warming. So I think very few scientists will tell you we have to do this tomorrow. But all of us will say, the sooner you do it, the cheaper it is, the better it is, and the less risk it is. Compare it to a medical thing, right? You go to your doctor and you say, well, you have a 20% chance of having a coronary next year. And you can either say, oh, I have 20%, I don't really care, or you can start doing something about it. And I think climate and ice sheets are in that place right now. Yeah?
Last year I went up to Newfoundland hoping to see the glaciers breaking off from Greenland and floating down, and I didn't see them.
Oh, no.
Well, but I'll go back. But is that A sign of climate warming? And B, are those glaciers, does anybody study them, and are they very helpful?
Sure. So the icebergs are coming from Greenland. They're breaking off the front of the ice where it's in the fjord, and then they're floating across the North Atlantic
Right.
and ending up in Labrador and Newfoundland. My understanding is the iceberg flux has actually increased. There are more icebergs than there used to be as the glaciers are more active and they're shedding more ice. I think it's just luck that you didn't see one there. In fact, they have been threatening some of the oil production facilities off eastern Canada because the last thing you want is a drilling rig out there when a big iceberg comes by. So they actually have towboats removing icebergs that could be threatening drilling rigs. It's one of the reasons that drilling for fossil fuels in Greenland is not economically particularly feasible, because you're working in a really cold environment, it's in the dark, and you have to guard against all these icebergs. And the other part is they haven't actually made many finds. And as you read a lot of the propaganda on Greenland, it talks about what a fossil fuel mecca it could be. Ted Cruz ran a Senate hearing that Christine can vouch. I was saying a lot of bad words during this thing for 2.5 hours of just propaganda. And there was a whole thing about, well, there's this report the U.S. Geological Survey wrote about all the fossil fuels in Greenland. When you go to look at that report, the title is Undiscovered Fossil Fuel Resources of Greenland. They took geologic maps and they said, this looks like the kind of place you're going to find fossil fuels. When they went and drilled for the 10 years after that, they didn't find any big economic, they didn't find North Slope oil or anything. So, you know, yeah.
But some of those glaciers, they say that broke off, that they're thousands of years old. So is it helpful to look at?
So the ice is thousands of years old.
Yes, that's what I'm trying to say.
The ice that's in the icebergs is thousands of years old. And yes, people have looked at that. In fact, some of the first measurements of sort of the layering in glaciers was done by the Danes in icebergs because it was an easy thing to sample. They didn't have drill cores at that point, so they went to the side of icebergs and they did the same thing. Yeah, exactly. Yes?
So, like 400,000 years of ice, do they see genetic drift?
Oh, that's fascinating. So the ice in Greenland, the oldest ice in Greenland is probably a little over 100,000 years, 120 maybe. The material we're working on is the frozen soil beneath the ice. So it's older than the ice. The Danes have done DNA analysis from that soil. They have done DNA analysis from the ice above. And everything they see, they can represent today. So in that 400,000 years, they don't see anything there's nothing different between what we see in the fossils and the DNA and what's in Greenland today. It's not been enough time. And it looks just like today's ecosystems. The only difference is we never found any mammal parts. The Danes found DNA from a pika, which is a little rodent-like thing that runs around on the rocks. We thought that was great. We were hoping for like a woolly mammoth. They didn't find woolly mammoth poop or anything, but they found the pika. Yes? So the question was other glaciers, other Arctic glaciers, the Antarctic. I focused on Greenland. There are certainly smaller Arctic glaciers that are melting rapidly in Alaska, for instance. The Antarctic is, an order of magnitude worse problem. Greenland is responding very quickly. It responded ahead of Antarctica. Now Antarctica is starting to respond. It holds several times more sea level rise. It's going to take a long time to melt a lot of Antarctica, but we could easily get 5 meters of sea level rise from West Antarctica quite quickly. They're both a problem, but they're both curable, right? And that's, I think, I'll finish up soon and I can just talk to people individually, but we have the means to solve this problem today, right? I'll just speak of our house personally. 30 years ago, we insulated a 100-year-old Victorian and cut our heating bills by 2/3. That's a doable technology. It was 30 years ago. Now we have a heat pump that uses half the power of the air conditioners we used to run and heats our house in the swing seasons really well. We drive an electric vehicle that's far more efficient than anything else we drove. We can all do those things. Solar power is cheaper to build than fossil fuel plants right now. So it's not like we don't have the technology to do this. We have the battery technology, we have the water storage technology to regenerate from intermittent solar. This is all a solvable problem. We don't have the societal will to do it right now. And if we do it, it will save both ice sheets. So, you know, we can either get at the root of the problem or we can deal with the consequences. And my argument, logically, is why don't we just deal with the root of the problem? And then the consequences will diminish. They're still there. We are still going to have to adapt to a changing climate. But I don't understand. This country put a man on the moon in, what, a decade? And I'll go even back to this Camp Century, which is how I closed the book. which says these guys had no clue in the 1940s how to live inside an ice sheet, how to operate militarily on an ice sheet, and within 10 years of research, they built camps with nuclear reactors inside an ice sheet. They learned how to transport, they learned how to fly. I know that's not the same as decarbonizing the global economy, but this was a set of really smart people who put their minds to doing something, had the resources to do it, and in a decade they did it. I don't understand why we can't do that in terms of getting off of fossil fuels. We just need the willpower to do it. And I'm baffled on how we get that willpower, but I really think it comes down to finding a way across this partisan divide that's set up in this country right now.
It comes down to finding a way around the money.
Agreed. Agreed.
It's not just the
But
partisan divide, it's about money, it's about corporate power.
it is about money, but yet the industry that cares most about climate change right now, anyone want to take a guess at that?
Reinsurance.
Insurance companies. That's big money, and they're losing big money. And so the reinsurance companies hire all these climate scientists. I'm going to bet you that a pile of the federal climate scientists who have been laid off or have resigned are going to end up in private insurance companies, these reinsurance companies predicting climate just the way they did for the US government, but for private entities. So I think the money's, you're right about the money, and you're right about the fossil fuel money. But I think as climate change ramps up and the damages are greater, there's going to be interest on money from the other side that says, we got to deal with this. So maybe I'm just being hopeful, but I tend to be a hopeful person. I don't think I could live with myself if all I did was sort of worry about the end of the world. And I think humans are smart, and I'll leave you with hope.